The quadratic formula gives us a strategy for solving any quadratic equation, provided that we're able to satisfy some initial conditions. The two main initial conditions are we want to ensure that our equation is actually quadratic, and we check that by making sure we have a square term. And the second condition is that we set our equation equal to 0. Once the equation is set equal to 0, you can identify the three coefficients / constants that we'll use in the quadratic formula. There's A, there's B, and there's C. It's always a good idea to write them separately so that you have an easier place to refer back to as you work through the formula. Also, you want to make sure that you take any signs in front of the numbers with the numbers. So the quadratic formula says we start with the opposite of B, plus or minus. That's how we're going to get our two potential roots. The square root of b squared minus 4ac. All of that over 2a. As you get more experience with the quadratic formula, you'll need to write less and less of the initial parts of the formula. For example, if I know that I'm beginning with the opposite of b, and b is a negative number, I could just jump right to knowing that that would be 4. In here, I can jump right to negative 4 squared is 16. And if I'm able to do this operation in my head, I can have that done as well, and I know that that's 8. We have a negative here times a negative there, giving us a positive in there. And then at the bottom, oh, my apologies, I should have written a 2 here as well in the place of the a. And in the bottom, we have a 4. We simplify this as much as we can using everything we know about simplifying radical expressions. 4 plus the square root of 24 over 4. 4 plus or minus. 4 has a perfect factor of 4, leaving behind a 6. So it simplifies to 2 root 6 over 4. And then we can go through a little bit of creative division, depending upon how we want to write this, exactly how we want to write this solution. All three of these terms are divisible by 2. So I can go through and divide everything by 2. I also could imagine it as I'm using a 2 from the denominator to simplify both of these factors. But either way, I'm ending up with, both of those terms. Either way, I'm ending up with 2 plus or minus root 6 over 2. That's a perfectly acceptable way to write the answer. There's no radicals in the denominator. We check that. And we're okay with leaving the plus minus because we understand that that represents the two different solutions. 2 root 6 over 2, and 2 plus root 6 over 2, and 2 minus root 6 over 2. You also can write out the solution set using our set notation, 2 plus root 6 over 2, 2 minus root 6 over 2, with our set brackets around it. Is that a necessary step? No, it's not a necessary step, but it's nice to have our work and our solutions organized in such a way that someone could see them directly. The key to remember for the quadratic formula is that this is really going to be used in those situations where everything else fails. If you cannot easily produce a graph, or if you need a more exact solution, a graph would only give you these potential solutions as approximate solutions, they're decimal expansions. If you can't factor, if you can't use the square root method, and if graphing technology fails, that's where the quadratic formula comes in. And none of those other methods would we be able to use to get these two exact solutions. So you want to be aware of those situations that we've seen before that make it a little bit easier. You don't want to jump right to the quadratic formula just because you know it's going to work.